Welcome to this video on the topic of vectors. In this lesson, we're going to go through the operations that we may use on vectors, those being addition, subtraction, and scalar multiplication. To begin with, we'll go through the manual operations of how we do this on pen and paper. After we've gone through those operations, we'll have a look at how we can use our technology to automate this for us. The operations of addition, subtraction, and scalar multiplication may be applied to vectors. Consider we have vector A, vector B, vector C, and then we have a scalar value k. What we're going to do is we're going to use these values over here to compute these examples down here. Now the first one we turn our attention to is vector A plus vector B. When we're doing this one, we start out by simply replacing the names of the vectors with the vector values themselves. In this case, it's going to be vector A plus vector B. Vector A is minus 3 and 5. Vector B is in unit vector form. So it's 2i minus 7j. Now if we're choosing to do these operations by hand, we have to make the choice of either turning both vectors into component vector form, as seen in A, or into unit vector form, as seen in B over here. For this example, I'm going to choose to use component vector form. In the next example, I'll do the opposite. So, moving on, I'm going to choose to convert vector B into component vector form. This will look like 2 minus 7. Next, when I'm doing vector arithmetic, I simply add the members of the vectors across the rows. So I can draw one big vector, and it's minus 3 plus 2, 5 plus minus 7. I simply use my integer arithmetic, and I come to the conclusion the solution for this is minus 1 and minus 2. So the way in which I chose to simplify this expression over here was I chose to convert both of my vectors into component vector form. Then I simply added across the rows because the operation was add. Alright, moving along. Next one is vector A take away vector B. First thing I do is I get my values and I key them in. So it's minus 3, 5. The operation is subtraction, and I'm going to have 2i minus 7j. Now from the geometric lesson we learned that when we take the negative of a vector we simply reverse it. Another way to think of it is you're adding a negative, so I'm going to change that a minus b into a plus minus b. Now I need to make the choice, do I want to represent both vectors as component vectors, or do I want to put them in unit vector form? Now because I chose to do it in component vector form in the last example, I'm going to choose to do this one in unit vector form. So vector A is going to be represented as minus 3i plus 5j. The next vector, it's a plus, negative, in fact, let's say it's plus, and then I'll bring the negative in the bracket, so it's minus 2i plus 7j. I now expand the brackets out, minus 3i plus 5j plus, and it will be minus 2i plus 7j. I now collect like terms, and I simplify. So my answer to this is minus 5i plus 12j. So the answer to this is written in unit vector form. I could write it in component form, but I choose to leave it like this because the question doesn't state which form it wants. Alright, next one. We go across to C. It's k times vector A plus C, vector C. Notice that k is a scalar value of 2. Vector A is indeed a vector still. Vector C is a vector 9 and minus 4. So what we're going to do is we're going to write this out by subbing the values in. It's going to be k was 2, A, we'll write it with the times symbol. A was minus 3 and 5, the operation is plus, and C is 9 and negative 4. Okay, this works in the same order as BADMAS. We do our multiplication and then we do our arithmetic of plus and minus. So first thing I need to do is I need to multiply both members of vector A by 2, because that's how a scalar multiplication works. We scale every member up by the scalar multiplication. So it's 2 by negative 3, it's 2 by 5, plus 9 and negative 4. Now I choose to add across the rows because that's how it works. 2 by negative 3 is going to be negative 6, and then it's plus 9. 2 by 5 is 10, plus negative 4. Finishing this off, it's going to be 3, and final one is going to be 6. And I write that in component form. So K times vector A plus vector C is 3 and 6. Okay, final one. We are going 1/3 of vector C. Now notice that in the definition, it only says that the operations of addition, subtraction, and scalar multiplication. If we say that we're doing 1/3 of vector C, then we might erroneously think that we're going to do division, where we'd say vector C divided by 3. But the problem with this is that division is not a vector operation. We cannot divide a vector. Now the way in which we get around this is we simply do scalar multiplication. So we dilate vector C by 1/3. So this is how we take 1/3 of a vector, or take a fifth or a half. We simply dilate it by 1 over something. Now this operation is going to look like 1 over 3 multiplied by vector C. We already know it's 9 and minus 4. So when we're taking care of this, we treat it like it's scalar multiplication. So this is going to be 1 over 3 times 9, 1 over 3 times minus 4, 9 over 3, negative 4 over 3. Hence, top one's 3, bottom one's just minus 4 over 3. We could put it as a mixed fraction, but there's no need to. So there's our operations. When we're trying to divide something, we don't divide it, rather we just multiply it by 1 over. So we always do scalar multiplication if we want to reduce something. So these are our examples of how we do vector arithmetic using vectors. Now let's have a look at how we can do it with technology. So we say up we come, and then what we're going to do is we're going to key all of these values here into our calculator. First thing I'm going to do is I'll just choose to clear my memory. I'll go to mapvec. I'll make sure I'm in vector mode by pressing F6, and then I'll key in the vectors A, B, and C. A is a 2 by 1. It is minus 3 and 5. Vector B, it's in unit vector form, so I'll convert it into component form. And then vector C. Okay. Now I can't put K in here because K is a scalar value, not a vector. So I'll go exit, and rather to put K in, I'll go 2, and then I'll use this symbol over here, the arrow, go alpha, and then I'll look for K. And K now represents the value 2. So if I go K, there we go, it's 2. Next one, let's do the first one, vector A plus vector B. To do this operation, I go to options, I go to vec or map vec, so F2, I go across, vec, vector A plus vec, vector B. Lo and behold, the same value. Next, I go for subtraction, vec, A minus B. I get minus 5 and 12, so this is what I got down here, except this is in the unit vector form. Next one, we're doing a scalar multiplication in there. So what I can do is I can say alpha K, I can then say vec alpha A, and then it's a alpha C, but I need to put the vector, and lo and behold we get 3 and 6. And then for the final one, we're going to go 1/3, so it's going to be 1/3. Then we put in our vector alpha C, and lo and behold it gives us the values we're anticipating there. So this is how we use technology to do the arithmetic operations over here. So in summary, what we had a look at was our vector arithmetic, knowing that we can do addition, subtraction, and scalar multiplication. We remember that division is not a vector operation, so it cannot be done. Rather, we choose to dilate by 1/, whatever we would like to divide by.